Above us, in the endless black between Earth and stars, a second world turns in perfect silence. 8,000 satellites orbit our planet at this very moment, each one a mechanical guardian spinning through the void. They form an invisible web around our world, a technological nervous system that pulses with radio waves, timing signals, and streams of data that flow down to touch every corner of human civilization. Most of us never think about this orbital kingdom. We wake, and our phones know exactly where we are because satellites whisper coordinates from 12,000 miles above. We check the weather because mechanical eyes in space watch storms gathering over distant oceans. We send messages that bounce from tower to tower, crossing continents in the time it takes to draw a breath. The stock markets open each morning synchronized to atomic clocks in orbit. Emergency responders navigate to accidents using guidance from machines that circle the Earth 16 times a day. This is the machinery of modern life, delicate, precise, and utterly dependent on the continued cooperation of systems we've launched beyond the atmosphere. These satellites are built like fortresses. They must survive solar storms that could strip paint from metal, cosmic radiation that would kill a human in minutes, and temperature swings that range from molten hot to absolute cold. They are designed to operate for decades in the most hostile environment we know, performing their silent duties while Earth turns below. And yet, something made them falter. In the autumn months of recent years, as an object called 3I Atlas drifted through our solar system, operators began noticing patterns. Satellites that had functioned flawlessly for years started exhibiting behaviors that technical manuals had no explanations for. Communication arrays would lose signal for exactly 47 seconds, then resume as if nothing had happened. GPS satellites reported position errors that violated the laws of orbital mechanics. Weather monitoring systems entered protective mode without any triggering event that sensors could detect. The incidents were subtle, brief, easy to dismiss as the normal wear and tear of machines operating in space. But they followed a timeline that aligned precisely with the passage of our interstellar visitor. 3I Atlas was unlike anything in our catalogue of wandering objects. Massive beyond typical asteroids, luminous in ways that defied conventional explanation, it moved through the inner solar system on a trajectory that seemed to intersect with the most sensitive zones of our orbital infrastructure. Not crashing into them, that would have been dramatic, obvious, impossible to ignore. Instead, it passed nearby with the quiet precision of something that knew exactly where our most important systems were positioned. Have you ever wondered what would happen if something from beyond our solar system could reach out and touch the technology you depend on every moment of every day? What would it mean if the satellites that guide your morning commute, predict your weather, and carry your voice across oceans could be influenced by forces we don't understand? The reports exist in technical databases, filed under routine maintenance logs and system anomaly reports. Language carefully chosen to describe the undescribable. Temporary communication loss, unexplained autonomous reset, attitude control drift of unknown origin. These are the words that institutions use when something happens that shouldn't be possible, but clearly did. In the measured, careful language of space agencies, extraordinary events become routine paperwork. Incident reports are generated, reviewed by committees, and archived in systems that few people query and fewer discuss. This is how the impossible becomes invisible, not through conspiracy or cover-up, but through the comfortable weight of bureaucratic process and our collective need for the world to make sense in predictable ways. But the patterns were there for anyone who knew how to look. Satellite operators working overnight shifts began to notice correlations. Control room displays that had shown steady green status lights for years started flickering amber during certain windows of time. Ground stations lost contact with orbital assets in sequences that felt too coordinated to be random. The timing was precise, almost surgical, as if something was methodically testing the response characteristics of our most sophisticated systems. Atlas passed closest to Earth during a period when solar activity was remarkably quiet. The Sun's magnetic field was stable, space weather conditions were nominal, and Earth's magnetosphere showed none of the disturbances that typically accompany satellite anomalies. By every conventional measure, our orbital infrastructure should have functioned perfectly during those weeks. Instead, machines that were built to withstand the fury of solar storms and cosmic radiation began responding to influences that our sensors couldn't detect. Systems designed to operate independently started entering safe mode simultaneously across different orbital altitudes. Communication satellites in geostationary orbit experienced the same types of anomalies as weather satellites in low Earth orbit, despite being separated by thousands of miles of vacuum. The disruptions weren't destructive. Nothing exploded, nothing crashed, nothing was permanently damaged. But for brief moments, the invisible web that connects our world to the cosmos above shivered. GPS timing signals wavered just enough to affect cellular network synchronization. Communication relays went silent just long enough for automated systems to log the events as temporary malfunctions of unknown origin. It was as if something had reached down from the darkness between worlds and gently touched our technological nervous system, not to break it, but to see how it would respond. Most of us continued our lives without noticing. The disruptions were too brief, too subtle, too easily explained away as the normal quirks of complex systems operating in harsh environments. But in control rooms around the world, operators began asking quiet questions about patterns that didn't fit their training manuals. Why were unrelated systems exhibiting similar behaviors? Why did the anomalies cluster around specific time windows? And why did the official reports seem to describe everything while explaining nothing? 3i Atlas completed its passage through the inner solar system and continued on its journey toward the outer darkness. The satellite anomalies gradually returned to normal statistical ranges. Incident reports were filed, reviewed, and archived. The extraordinary became routine. The inexplicable became footnotes in technical databases that few would ever read. But questions linger in the spaces between official explanations. Questions about what happens when something from beyond our world interacts with the delicate machinery we've placed in the void above us. Questions about whether the timing of Atlas's passage and our satellite disruptions was cosmic coincidence or something far more deliberate. In the endless conversation between Earth and sky, sometimes the most important messages are delivered not through what we clearly hear, but through the moments when we realize we've been listening to carefully orchestrated silence. What if our invisible guardian network, spinning silently in the darkness above, had been touched by something that wanted to understand how we'd learned to reach beyond our atmosphere? What if those brief moments of disruption weren't accidents, but gentle probes designed to map the nervous system of human civilization? As we drift towards sleep tonight, wrapped in the comfort of technologies we rarely consider, 8,000 mechanical sentries continue their eternal dance around our world. They pulse with radio signals, stream data across invisible pathways, and maintain the delicate connections that hold our modern world together. But now we know they can be touched by visitors from the dark between stars. And we're left to wonder, was 3i Atlas simply passing through our solar system? Or was it conducting the first systematic test of defenses we never knew we'd built? To understand what happened during those strange autumn weeks, we must first appreciate the invisible kingdom that humanity has built in the void above our heads. It is a realm of mechanical precision, where timing is measured in nanoseconds, and positions are calculated to within inches across distances of thousands of miles. Imagine for a moment the delicate choreography unfolding above us right now. In low Earth orbit, just a few hundred miles up, weather satellites race around our planet every 90 minutes, the cameras and sensors constantly scanning cloud formations, temperature gradients, and atmospheric pressure systems. They move so fast that they experience 16 sunrises and sunsets every day, yet they maintain their precise paths with mathematical certainty. Higher up, in medium Earth orbit at 12,000 miles altitude, 24 GPS satellites trace lazy circles around our world. These are the timekeepers of modern civilization. Each one carries atomic clocks that tick with accuracy beyond human comprehension, losing less than a second every 100,000 years. They broadcast timing signals continuously, creating an invisible grid of temporal precision that synchronizes everything from banking transactions to traffic lights. And in the highest realm, 22,000 miles above the equator, the geostationary satellites hang motionless relative to Earth's surface. Communication satellites in this orbital zone appear to hover over fixed points on our planet, serving as relay stations for television broadcasts, internet traffic, and military communications. They are humanity's eyes and voice in the cosmic dark, perpetually watching and listening and speaking across the void. This three-layered constellation forms the technological nervous system of our species. Every GPS navigation on your morning commute relies on signals from satellites moving at 17,000 miles per hour. Every weather forecast begins with data gathered by mechanical observers that see our planet from the perspective of the gods. Every international phone call, every streaming video, every emergency dispatch, all of it flows through this orbital network that most of us never think to look up and acknowledge. The satellites themselves are marvels of engineering resilience. They must operate in an environment that would destroy most human-made objects within hours. Space is not empty. It seethes with radiation, micrometeoroids, and particles ejected from the sun at millions of miles per hour. Temperatures swing from 250 degrees above zero in sunlight to 400 degrees below zero in shadow. There is no air to carry away heat, no atmosphere to burn up incoming debris, no rescue mission possible if something goes wrong. So these machines are built like digital fortresses. Their electronics are hardened against radiation that would scramble computer memory and corrupt data. Their solar panels can fold and unfold thousands of times without mechanical failure. Their attitude control systems use gyroscopes, reaction wheels, and tiny thruster jets to maintain precise orientation, despite the constant push and pull of gravitational forces, solar wind, and orbital mechanics. Each satellite represents hundreds of millions of dollars in development, years of planning, and the accumulated knowledge of thousands of engineers. They are launched on rockets that cost additional hundreds of millions, placed into orbits calculated with extraordinary precision, and then expected to function autonomously for 10, 15, even 20 years without any possibility of hands-on repair. The redundancy built into these systems is staggering. Multiple backup computers, duplicate communication arrays, spare reaction wheels, emergency power modes. Every critical system has alternatives, and every alternative has fail-safes. The engineers who design orbital infrastructure assume that space will try to destroy their machines, and they plan accordingly. But even the most robust systems have vulnerabilities. The electronics that allow satellites to think and communicate are fundamentally sensitive to electromagnetic interference. Solar storms can overwhelm their radiation shielding. Charged particles can accumulate on spacecraft surfaces until they discharge in sparks that damage circuits. The very technologies that make satellites intelligent, computer processors, memory banks, radio transmitters, are precisely the components most susceptible to interference from sources we don't always understand. Ground control centers monitor these vulnerabilities constantly. In windowless rooms filled with banks of monitors, operators watch over their orbital flocks like shepherds tending electronic sheep. They track each satellite's position, power levels, communication status, and system health. When anomalies occur, a temporary loss of signal, an unexpected attitude drift, a computer reset, the operators log the incident, analyze the data, and file reports in databases that document every unusual behavior. This is where the patterns began to emerge during our visitor's passage. Operators who had monitored the same satellites for years started noticing correlations they had never seen before. Systems that typically operated independently began exhibiting synchronized anomalies. Satellites in different orbital zones, built by different manufacturers, launched years apart, started reporting similar types of malfunctions during the same narrow time windows. The timing was surgically precise. Communication satellites would lose carrier lock for exactly 47 seconds, then resume normal operation. GPS satellites would report phantom position errors that lasted for specific durations before self-correcting. Weather monitoring systems would enter protective safe mode simultaneously across different orbital altitudes, despite showing no triggering conditions that their sensors could detect. These weren't the random failures that space-hardened systems occasionally experience. Random failures follow statistical distributions, some lasting seconds, others lasting hours, scattered across time in patterns that reflect the chaotic nature of space weather and equipment aging. What operators observed during our visitor's passage was different. The anomalies clustered around predictable time intervals. They affected unrelated systems in coordinated ways. They began and ended with timing that suggested external influence rather than internal malfunction. Most critically, they occurred during a period when every conventional source of satellite interference was remarkably quiet. Solar activity was minimal, no coronal mass ejections, no significant solar flares, no unusual radiation bursts. Earth's magnetic field was stable, creating none of the geomagnetic disturbances that typically precede satellite anomalies. Space weather monitoring stations around the world recorded conditions as nominal, routine, unremarkable. By every established protocol for satellite operations, those autumn weeks should have been a period of perfect functionality. The orbital environment was as benign as it ever gets. Ground control centers should have monitored nothing more dramatic than routine telemetry and standard orbital adjustments. Instead, they observed their machines responding to influences that didn't appear on any sensor, following patterns that fit no operational manual, exhibiting behaviors that suggested coordination by forces beyond the established parameters of space weather and orbital mechanics. The satellite network that had been designed to resist the fury of solar storms, the bombardment of cosmic rays, and the endless hostility of the space environment was responding to something far more subtle, something that touched these orbital fortresses not with brute force, but with precision, as if it understood exactly how human technology functioned and exactly where its sensitivities lay. In the careful language of incident reports, operators documented these events with clinical terminology: temporary communication anomaly, unexplained attitude disturbance, autonomous safe mode activation of unknown origin. But between the lines of technical jargon, a different story emerged, a story of systems that had been touched by something that understood their vulnerabilities better than their own designers. The disruptions weren't destructive, nothing was permanently damaged, no satellites were lost, no critical services experienced extended outages, but they were demonstrative, as if something was conducting a gentle audit of our orbital capabilities, testing response times, measuring recovery procedures, mapping the extent and sophistication of the technological web we had woven around our world. As our interstellar visitor continued its journey through the inner solar system, the satellite anomalies gradually diminished. Systems returned to their normal operational parameters. Incident reports were filed, reviewed, and archived. The extraordinary returned to the statistical background noise of routine space operations, but the questions remained. How had machines built to withstand the most extreme environment in our solar system been influenced by something that left no detectable signature on our instruments? What kind of phenomenon could affect satellites across multiple orbital zones with surgical precision while remaining completely invisible to the sensors designed to monitor space weather and electromagnetic interference? And perhaps most unsettling of all, if our visitor could touch our orbital infrastructure so precisely, what else might it have learned about the civilization that had built these mechanical guardians in the first place? The satellites continue their eternal dance above us tonight, pulsing with radio signals and streaming data across invisible pathways. They maintain the connections that hold our technological civilization together, just as they did before our visitor's passage, and just as they have every day since. But now we know that this orbital kingdom, for all its engineering sophistication and redundant safeguards, can be touched by forces we don't understand and influences we can't detect. The machinery above us is not as isolated from the cosmic dark as we once believed, and in that realization lies a question that echoes in the spaces between our satellites' radio signals. What happens to a civilization that discovers its most protected technologies can be gently manipulated by something that understands them better than their creators do? The first pattern emerged in the technical logs of 3 communication satellites orbiting above different continents. On the same October evening, at intervals separated by exactly 18 minutes, each satellite experienced what operators initially classified as a temporary carrier signal dropout. The events lasted 47 seconds each, no more, no less. When communication resumed, the satellites showed no diagnostic errors, no system warnings, no indication that anything unusual had occurred. 47 seconds is an eternity in satellite communications, long enough for automated systems to detect the loss and begin failover procedures, long enough for ground controllers to notice amber warning lights on their status displays, long enough to generate incident reports that would require explanation and documentation. Yet the satellites themselves recorded these events as routine operational status, as if the disruptions had never happened. This disconnect between ground observations and satellite self-reporting became the signature characteristic of the anomalies that would follow. Over the next 3 weeks, operators around the world began documenting a catalogue of impossible events. GPS satellites that reported their positions as fluctuating by several meters per second, despite being in perfectly stable orbits. Weather monitoring systems that simultaneously entered protective safe mode across 4 different orbital altitudes, then resumed normal operation without any triggering event recorded by their environmental sensors. The language of the incident reports tells its own story. In the sterile terminology of aerospace engineering, operators struggled to describe phenomena that their training manuals had no categories for. Unexplained autonomous reset sequence, attitude control drift of unknown origin, communication array experiencing temporary functionality suspension without detectable cause. Each phrase was carefully chosen to describe the observable facts while acknowledging that the underlying mechanisms remained completely mysterious. What made these events particularly unsettling was their precision. Random satellite failures follow predictable patterns. They cluster around periods of high solar activity. They affect older systems more frequently than newer ones. They tend to involve specific components that are known to be vulnerable to space weather. The anomalies occurring during our visitors' passage violated all of these established patterns. New satellites experienced the same types of disruptions as decade-old systems. Military communication platforms, built to the most rigorous specifications and operated with the highest security protocols, reported identical anomaly profiles to civilian weather monitoring satellites. The timing was coordinated across orbital zones in ways that suggested external influence rather than coincidental system failures. Perhaps most remarkably, the disruptions seemed to understand the architecture of human technology. GPS satellites didn't lose power or tumble out of control. They simply reported position errors that were significant enough to trigger automated error correction protocols, but subtle enough to remain within the bounds of what ground systems might interpret as temporary computational glitches. Communication satellites didn't broadcast random noise. They cleanly dropped carrier signals in ways that mimicked routine maintenance procedures. Ground control centers began comparing notes through informal channels. Operators who had worked the night shift for years started recognizing patterns in conversations over secure communication lines. The disruptions weren't affecting all satellites equally. They seemed to target specific types of systems during predictable time windows. Navigation satellites would experience anomalies during one 4-hour period, then communication platforms would show disturbances during the next window, followed by Earth observation systems. The sequence suggested methodical assessment rather than random interference, as if something was systematically testing different categories of human orbital technology, cataloguing their response characteristics, mapping their operational parameters. Each type of satellite was probed during its own dedicated time window, allowing for careful observation of how ground controllers detected, analysed, and responded to each category of anomaly. The bureaucratic response to these events followed predictable institutional patterns. Incident reports were generated according to standard protocols. Technical analysis teams reviewed the data and found no smoking guns, no clear causative mechanisms, no violations of known physical principles that would require immediate escalation. The anomalies fit into the grey zone of operational aerospace engineering, unusual but not catastrophic, mysterious but not threatening, significant enough to document but not dramatic enough to trigger emergency procedures. This is how extraordinary events become invisible in large organisations, not through active suppression or deliberate cover-up, but through the comfortable weight of established procedures and the human tendency to normalise unusual experiences when they don't fit existing conceptual frameworks. The anomalies were duly recorded, properly analysed, and appropriately filed. They became data points in technical databases that few people outside the satellite operations community would ever query. But the patterns persisted in those databases for anyone who knew how to look. Correlation analysis revealed timing relationships that couldn't be explained by coincidence. Statistical modelling showed that the probability of such coordinated anomalies occurring naturally during the same time period was effectively zero. The data painted a clear picture of systematic external influence, even though no instruments had detected any source of such influence. The mystery deepened when operators began reviewing historical data from previous years. Similar anomaly patterns had never been recorded during periods when the solar system contained only its normal complement of planets, moons, asteroids, and comets. The baseline statistical noise of satellite operations showed nothing comparable to the coordinated disruptions that occurred during our visitor's passage. Whatever was affecting these systems was not part of the established space environment that satellite engineers had learned to anticipate and design for. Environmental monitoring stations detected no unusual electromagnetic emissions during the anomaly windows. Radio telescope networks recorded no significant changes in background radiation or artificial signal activity. Space weather instruments showed conditions that were remarkably stable, far more benign than the chaotic electromagnetic environment that typically accompanies satellite disturbances. The absence of detectable causative mechanisms became as significant as the presence of the anomalies themselves. Satellite systems were responding to influences that existed below the threshold of human sensing technology. Something was interacting with our orbital infrastructure using methods that remained completely invisible to the instruments we had developed to monitor the space environment. As our interstellar visitor reached its closest approach to Earth, and then began its journey toward the outer solar system, the anomaly patterns shifted in ways that correlated precisely with orbital mechanics calculations. The disruptions didn't end abruptly. They faded gradually, following a timeline that matched the visitor's changing position relative to Earth's satellite populations. Systems closer to the visitor's trajectory experienced effects for longer periods than those in more distant orbital zones. This correlation provided the clearest evidence that the satellite anomalies were somehow connected to our cosmic visitor's passage. The timing was too precise, the spatial relationships too exact, the fade-out pattern too perfectly aligned with gravitational and electromagnetic field calculations to be explained by coincidence. Something about our visitor's presence in the inner solar system was affecting human technology in ways that conventional physics couldn't account for. The final anomaly reports were filed in December, weeks after our visitor had passed beyond Mars' orbit and begun its journey back toward interstellar space. Satellite operations gradually returned to their normal statistical baselines. The coordinated disruptions disappeared as mysteriously as they had appeared, leaving only archived data files and technical reports as evidence that anything unusual had occurred. But those reports contained enough information to reconstruct a clear sequence of events. Over the course of 6 weeks, something had systematically interacted with Earth's orbital infrastructure. It had probed our navigation systems, tested our communication networks, and assessed our Earth observation capabilities. It had done so with surgical precision, affecting specific satellite functions during predictable time windows while leaving no detectable signatures that ground-based instruments could identify. The implications were staggering. Our visitor hadn't simply passed through the inner solar system. It had conducted a methodical survey of human technological capabilities. It had learned how we navigated, how we communicated, how we monitored our own planet from space. And it had accomplished this reconnaissance while remaining effectively invisible to the sensing networks we had developed to monitor threats and anomalies in the space environment. In the months that followed, satellite operations continued their normal routines. New systems were launched, older ones were decommissioned, routine maintenance and upgrades proceeded according to established schedules. The extraordinary weeks of coordinated anomalies faded into the background noise of bureaucratic memory, becoming historical footnotes in technical databases that few would ever examine. But questions echoed in the spaces between official explanations. If something could touch our most sophisticated orbital systems without triggering our detection networks, what other capabilities might it possess? If our visitor could map human technology with such precision, what conclusions might it have drawn about the civilization that had built these mechanical guardians? And perhaps most unsettling of all, if those weeks of subtle disruptions were not accidents but assessments, what might our orbital infrastructure have revealed about our strengths, our vulnerabilities, and our readiness for contact with intelligences that understood our technology better than we understood theirs? The satellites continue their silent dance above us, maintaining the invisible connections that bind our technological civilization together. But now we know that this orbital kingdom can be touched by visitors who leave no fingerprints on our instruments, who can map our capabilities without triggering our alarms, who can assess our defenses while remaining completely hidden from our most sophisticated detection systems. In the gentle precision of those disruptions, we glimpsed something far more profound than random cosmic interference. We saw evidence of intelligence that could reach across the void and touch our machines with the delicate accuracy of a surgeon's hand, learning everything it needed to know about human civilization without ever announcing its presence to those who built the systems it was studying. When satellite systems begin exhibiting coordinated anomalies, the first instinct of any competent aerospace engineer is to examine the space weather data. Solar storms, coronal mass ejections, and geomagnetic disturbances are the usual suspects when orbital infrastructure misbehaves. These phenomena follow well-understood patterns, produce predictable effects, and leave clear signatures in the instruments we use to monitor the electromagnetic environment around Earth. During the weeks of our visitors' passage, space weather conditions were not just normal, they were remarkably quiet. The Sun's magnetic field showed none of the complex reconnection events that typically precede solar flares. Coronal holes, those regions where the solar wind streams away from our star at accelerated speeds, were small and stable. The interplanetary magnetic field maintained steady orientation and intensity. By every measure that space weather forecasters use to predict satellite disruptions, those autumn weeks should have been a period of perfect orbital tranquility. Solar activity follows an 11-year cycle of rising and falling intensity, and our visitors' passage occurred during what astronomers call the solar minimum, the quietest phase of this cycle. Sunspot counts were near zero. Solar radio emissions were at baseline levels. The charged particle environment around Earth was as benign as it ever gets. Satellites operating during these conditions typically experience their longest periods of uninterrupted service and their lowest rates of anomalous behaviour. Yet it was precisely during this period of solar quiescence that Earth's orbital infrastructure began responding to influences that left no signatures in our monitoring networks. The next logical explanation involves Earth's magnetosphere, the magnetic bubble that surrounds our planet and deflects most of the charged particles streaming away from the Sun. Disturbances in this protective field can create conditions that interfere with satellite electronics, particularly in the regions where the field lines converge near the magnetic poles. Geomagnetic storms can induce currents in spacecraft wiring, disrupt radio communications, and cause satellites to experience drag from expanded atmospheric layers. But magnetometer stations around the world recorded magnetic field stability that was well within normal parameters throughout our visitors' passage. The Aurora monitoring networks that track geomagnetic disturbances showed minimal activity. The KP index, which measures global geomagnetic disturbance levels on a scale from 0 to 9, rarely exceeded values of 2 or 3, indicating conditions so quiet that most satellite operators would consider them ideal for routine operations. Ground-based magnetometers are sensitive enough to detect magnetic field fluctuations caused by lightning strikes thousands of miles away. Yet they recorded no anomalous signatures during the time windows when satellites were experiencing coordinated disruptions. Whatever was affecting our orbital systems was operating below the threshold of our most sensitive electromagnetic monitoring instruments. Atmospheric scientists proposed that upper atmosphere dynamics might explain the anomalies. The thermosphere, where many low Earth orbit satellites operate, can expand and contract based on solar heating, creating changes in atmospheric density that affect satellite orbits and attitude control systems. But atmospheric monitoring showed conditions that were unusually stable during our visitors' passage. Thermospheric density remained within expected parameters. No significant atmospheric gravity waves or heating events were detected. The cosmic ray environment provides another potential explanation for satellite anomalies. High-energy particles from deep space can penetrate satellite shielding and cause single-event upsets in computer memory, leading to system resets and operational anomalies. But cosmic ray monitoring stations showed flux levels that were typical for solar minimum conditions. The galactic cosmic ray intensity was elevated, as expected when solar activity is low and the Sun's magnetic field provides less shielding, but it remained within the range that satellite systems are specifically designed to tolerate. More sophisticated analysis focused on the electromagnetic spectrum. Satellites are sensitive to radio frequency interference across a wide range of wavelengths. Military radar systems, radio astronomy installations, and various industrial processes can sometimes create electromagnetic signatures that affect orbital systems. but spectrum monitoring revealed no unusual activity during the anomaly time windows. Radio telescopes around the world were specifically tasked to search for artificial signals or unusual electromagnetic emissions that might correlate with the satellite disruptions. The results were consistently negative. No radio frequency interference, no unusual plasma wave activity, no electromagnetic pulses or field fluctuations that could account for the coordinated anomalies affecting multiple satellite systems across different orbital altitudes. The absence of detectable causative mechanisms became increasingly significant as the investigation continued. Satellite anomalies don't occur in a vacuum. They are always accompanied by measurable changes in the space environment. Solar particle events leave signatures in radiation detectors. Geomagnetic disturbances register on magnetometers worldwide. Radio frequency interference appears in spectrum analyzers. Atmospheric disturbances show up in thermospheric monitoring networks. But the disruptions during our visitor's passage occurred without any of these accompanying signatures. Satellite systems were responding to influences that existed completely outside the range of human detection capabilities. Something was interacting with our orbital infrastructure using mechanisms that remained invisible to every type of sensor we had developed to monitor the space environment. This raised profound questions about the nature of the phenomenon. Natural space weather events, no matter how subtle or complex, always leave some trace in our monitoring networks. The electromagnetic spectrum is vast, but our instruments span from extremely low-frequency radio waves to gamma rays. Our magnetometers can detect field fluctuations measured in nanoteslars. Our particle detectors respond to individual high-energy events. The idea that a natural phenomenon could affect satellite electronics while remaining completely undetectable by ground-based instruments challenged fundamental assumptions about how space weather works. Some researchers proposed that our visitor might be ejecting particles or electromagnetic radiation in frequencies or intensities that our instruments weren't designed to monitor. But spectroscopic analysis of our interstellar guest showed it to be remarkably inactive. Unlike comets, which develop bright tails as they approach the sun and begin outgassing volatile materials, our visitor remained essentially unchanged throughout its passage through the inner solar system. Infrared telescopes detected no significant thermal emissions that would indicate active material ejection. Ultraviolet observations showed no ionized gas clouds surrounding the object. Radio telescopes found no evidence of plasma interactions or electromagnetic activity. By every measure that astronomers use to assess the activity level of solar system objects, our visitor appeared to be completely inert, a dark, solid body that absorbed sunlight without exhibiting any of the dynamic behaviors that might affect nearby spacecraft. The contrast between our visitor's apparent inactivity and the coordinated satellite anomalies created a paradox that conventional space science couldn't resolve. Inactive objects don't generate electromagnetic fields strong enough to affect satellites. Solid bodies traveling through space don't emit particles or radiation that could interfere with orbital electronics. The laws of physics, as we understand them, provided no mechanism by which a passive interstellar object could systematically disrupt technological systems across multiple orbital zones. Yet the timing correlations were undeniable. Statistical analysis showed that the probability of such coordinated anomalies occurring naturally during our visitor's passage was effectively zero. The spatial relationships between our guest's trajectory and the affected satellite systems followed patterns that suggested direct causation rather than coincidence. The fade-out characteristics matched orbital mechanics calculations with precision that ruled out random correlation. As conventional explanations failed one by one, some researchers began exploring more exotic possibilities. Could our visitor be composed of materials that interacted with electromagnetic fields in ways that terrestrial physics hadn't yet discovered? Could it be generating effects through gravitational mechanisms that operated on scales smaller than our instruments could detect? Could it be utilizing physical principles that human science had not yet recognized or understood? These questions pushed against the boundaries of established scientific knowledge. Our understanding of fundamental physics is based on observations and experiments conducted within our solar system and immediate cosmic neighborhood. An object originating from interstellar space might operate according to physical principles that we had never encountered. utilizing mechanisms that remained invisible to instruments designed to monitor familiar phenomena. But even exotic physics couldn't easily explain the precision and apparent intelligence of the satellite disruptions. The anomalies weren't random effects of unknown natural forces. They followed patterns that suggested deliberate interaction with human technology. Systems were affected during specific time windows in coordinated sequences, with surgical precision that seemed to understand the operational characteristics of different satellite types. Natural phenomena, no matter how exotic, don't typically exhibit this kind of systematic behavior. They don't coordinate their effects across different technological systems. They don't target specific satellite functions while leaving others undisturbed. They don't follow time sequences that appear designed to test human response capabilities and assessment procedures. The accumulated evidence pointed toward a conclusion that challenged fundamental assumptions about the nature of our cosmic visitor. The satellite disruptions weren't side effects of natural processes, they were manifestations of intentional activity. Something associated with our interstellar guest was deliberately interacting with Earth's orbital infrastructure, using methods that remained completely outside the range of human detection and understanding. This realization transformed the entire context of our visitor's passage through the inner solar system. What had initially appeared to be a routine astronomical event, the detection and observation of another interstellar object, had become something far more profound. Our guest wasn't simply traveling through our cosmic neighborhood, it was actively studying the technological civilization it encountered here. The implications were staggering. If our visitor could map human satellite capabilities with such precision while remaining undetectable to our monitoring networks, what other activities might it have conducted during its passage? What other aspects of human civilization might it have assessed? What conclusions might it have drawn about our technological sophistication, our defensive capabilities, our readiness for contact with intelligences that operated according to principles we didn't understand? As our interstellar guest continued its journey toward the outer solar system and beyond, the satellite anomalies gradually faded to statistical insignificance. But the questions raised by those weeks of impossible disruptions continued to echo in the spaces between official explanations. We had encountered something that challenged our understanding of what was natural and what was artificial, what was possible and what was impossible, what was random and what was intentional. Our visitor had demonstrated capabilities that exceeded our current scientific frameworks, while conducting activities that appeared designed to assess the technological civilization it had discovered orbiting a yellow star in an unremarkable corner of the galaxy. In the gentle precision of those satellite disruptions, we had glimpsed evidence of intelligence that operated by rules we didn't understand, using methods we couldn't detect, pursuing purposes we could only begin to imagine. And in that glimpse, we discovered that our place in the cosmic order might be far different from what we had assumed. The universe, it seemed, was not as empty or as indifferent as we had believed. And something in that vast darkness was taking a very careful look at what humanity had built in the space above our heads. In the pre-dawn hours of any ordinary morning while most of the world sleeps, a silent symphony of technological coordination unfolds above our heads. GPS satellites broadcast timing signals that synchronize cellular networks across continents. Communication platforms relay financial transactions between markets that never close. Weather monitoring systems track storm systems that won't make headlines until hours later. All of this happens automatically, invisibly, without fanfare or acknowledgement from the billions of people whose daily lives depend on these orbital machines functioning with perfect precision. We have built our modern civilization on a foundation of invisible dependencies. The coffee shop where you buy your morning coffee relies on satellite-synchronized payment processing to handle your credit card transaction. The navigation system that guides your commute receives position updates from mechanical guardians 12,000 miles above your head. The weather forecast that determines whether you carry an umbrella comes from satellites that can see hurricanes forming over empty ocean days before they threaten populated coastlines. These connections are so seamless, so perfectly integrated into the fabric of daily life, that we rarely pause to consider how fragile they might be. We've created a technological nervous system that spans the globe and reaches beyond the atmosphere, yet most of us remain blissfully unaware of the delicate interdependencies that keep this system functioning. Consider the global positioning system that has become so fundamental to modern life that we take it for granted. Those 24 satellites orbiting in medium Earth orbit don't just provide navigation services, they serve as the master clock for technological civilization. Every GPS satellite carries atomic clocks that maintain time with precision beyond human comprehension, losing less than a nanosecond per day. These timing signals synchronize everything from stock market transactions to power grid switching operations. When you swipe your credit card at a store, the transaction timestamp comes from GPS satellites. The cellular towers that carry your phone calls synchronize their operations using GPS timing. Internet data packets route through networks that depend on satellite-derived timestamps to maintain proper sequencing. Even traffic lights in many cities coordinate their timing using signals from space. This temporal precision is so critical that financial markets have backup atomic clocks in case GPS timing fails, and power companies maintain separate time synchronization systems to prevent cascading blackouts. The failure of GPS timing signals for even a few minutes could disrupt banking systems, telecommunications networks, and electrical grids across entire continents. But timing is just one thread in the web of satellite dependencies that supports modern civilization. Communication satellites carry internet traffic across oceans, enabling the global information networks that have become essential to commerce, education, and social interaction. Without these orbital relay stations, international communication would return to the bandwidth limitations of underwater cables, creating bottlenecks that would fundamentally alter the pace and scale of global connectivity. Weather satellites provide the data that allows meteorologists to track developing storm systems and issue warnings that save lives. Hurricane forecasting depends on continuous monitoring from multiple orbital platforms that can observe atmospheric conditions across entire ocean basins. Without this space-based weather monitoring, coastal communities would have hours rather than days to prepare for major storms. Earth observation satellites monitor agricultural conditions, track deforestation, detect oil spills, and observe climate change indicators that inform policy decisions affecting billions of people. These mechanical eyes in the sky provide the global perspective that no ground-based monitoring system can achieve, allowing humanity to understand and respond to environmental changes on planetary scales. The removal of any single category of satellite services would create disruptions that would cascade through interconnected technological systems in ways that most people never imagine. But the removal of all satellite services simultaneously would represent a civilizational catastrophe, comparable to the loss of electricity or the failure of the internet. This is the shadow side of our technological sophistication. We have created systems so advanced, so perfectly integrated, so seamlessly invisible, that we have forgotten how dependent we have become on their continued operation. Our orbital infrastructure has become as essential to modern life as roads, bridges, and power lines, yet it operates in an environment that is fundamentally hostile and completely beyond our direct control. During those strange weeks when our interstellar visitor passed through the inner solar system, something touched this invisible foundation of technological civilization. The disruptions were subtle, temporary, precisely targeted, but they revealed vulnerabilities that few had considered and fewer still had prepared for. The satellite anomalies weren't random system failures. They were surgical probes that seemed to understand exactly where the pressure points of human technology were located. GPS satellites experienced timing disruptions that tested the resilience of ground-based synchronization systems. Communication platforms lost carrier signals during time windows that forced operators to activate backup procedures and redundant pathways. Weather monitoring systems entered safe mode in sequences that revealed how quickly ground controllers could detect and respond to unexpected anomalies. It was as if something was conducting a comprehensive assessment of human technological dependencies, mapping the critical pathways that keep modern civilization functioning, identifying the single points of failure that could cascade into widespread disruption. Ancient myths speak of sky gods who could steal fire from mortals, celestial beings who could silence voices across the land, heavenly forces that could disrupt the natural order with subtle interventions rather than dramatic displays of power. These stories, dismissed as primitive superstitions by modern rational thinking, take on different meanings when viewed through the lens of our satellite-dependent civilization. What would ancient peoples have called the sudden failure of long-distance communication? How would they have described the loss of navigation capabilities that left travelers unable to determine their position? What mythological framework would they have used to explain the simultaneous disruption of systems across vast geographical areas? The language would have been different, but the fundamental experience would have been the same: the realization that forces beyond human understanding could reach down from the heavens and touch the essential systems that societies depended upon for their continued functioning. Our modern technological society has created its own version of this ancient vulnerability. We have placed critical infrastructure beyond the Earth's atmosphere in a realm that we can monitor but cannot directly access, protect, or repair. We have made ourselves dependent on machines that operate in an environment where the rules of terrestrial engineering don't apply and where help is always thousands of miles away. The precision of the disruptions during our visitor's passage suggested something far more sophisticated than random interference. The anomalies targeted specific satellite functions while leaving others undisturbed. They occurred during predictable time windows that allowed for careful observation of human response procedures. They affected systems across multiple orbital zones in ways that reveal the full scope and interconnectedness of Earth's technological infrastructure. Most unsettling was the surgical accuracy with which these probes identified the most critical vulnerabilities. GPS timing disruptions lasted just long enough to trigger automated backup systems without causing permanent synchronization failures. Communication blackouts affected primary channels while leaving emergency frequencies operational. Weather satellite anomalies occurred during time windows when ground-based monitoring could provide temporary coverage. It was as if something was testing not just the technical capabilities of human orbital infrastructure, but the institutional responses to unexpected failures. How quickly could operators detect anomalies? What backup procedures would they activate? How effectively could ground-based systems compensate for temporary satellite failures? How well did different agencies coordinate their responses to simultaneous disruptions across multiple satellite systems? These were not the kinds of questions that natural phenomena typically pose. Random space weather events don't conduct systematic assessments of human technological resilience. Solar storms don't time their effects to evaluate emergency response procedures. Cosmic ray bursts don't coordinate their impacts to map the interdependencies between different satellite systems. The disruptions revealed something profound about the nature of modern technological civilization. We have created a global nervous system that extends beyond our planet, but we have also created new categories of vulnerability that previous generations never had to consider. Our satellites operate in an environment that we can observe but not control, where the failure of a few critical systems could cascade into disruptions affecting billions of people. The psychological impact of this realization extends beyond technical concerns. We have built our technological civilization on the assumption that space is empty, that the environment beyond our atmosphere is hostile but predictable, that the machines we launch into orbit will encounter nothing more complex than radiation, micrometeoroids, and the occasionally dramatic but well-understood effects of solar activity. The satellite anomalies during our visitor's passage challenged these fundamental assumptions. They suggested that space might not be as empty as we believed, that the cosmic environment might contain intelligences capable of interacting with human technology in ways that our scientific frameworks couldn't predict or explain. This possibility transforms our understanding of what it means to be a technological civilization. We are not alone in developing the capability to build machines that operate beyond planetary atmospheres. We are not the only intelligence that has learned to use electromagnetic radiation for communication and coordination. We are not necessarily the most sophisticated civilization in our cosmic neighborhood. The gentle precision with which something touched our orbital infrastructure during those autumn weeks suggested capabilities that exceeded current human understanding. The ability to affect satellite systems without triggering detection instruments. The knowledge of exactly where our most critical vulnerabilities were located. The coordination required to conduct systematic assessments across multiple orbital zones simultaneously. These capabilities implied not just technological sophistication, but intimate understanding of how human civilization had organized itself in space. Our visitor, or something associated with it, seemed to know more about our orbital infrastructure than many of the people who had built and deployed it. As our interstellar guest continued its journey toward the outer solar system, the satellite anomalies faded and normal operations resumed. But the implications of those weeks of impossible disruptions continued to echo through the consciousness of anyone who understood what had happened. We had built a technological nervous system that reached beyond our planet, and something had touched it with invisible fingers. We had created dependencies on machines operating in environments we couldn't directly access or control, and something had demonstrated that these machines were more vulnerable than we had assumed. In the invisible web of satellites spinning above our heads tonight, maintaining the connections that hold modern civilization together, we now recognize both the extraordinary achievement of human technological capability and the profound vulnerabilities that accompany our reach beyond the Earth's protective atmosphere. Something in the cosmic darkness knows how to touch our machines. Something understands our dependencies better than we understand them ourselves. And something has conducted a careful assessment of the technological civilization that humanity has built in the space between Earth and stars. The question that haunts the spaces between our satellites' radio signals is not whether we are alone in the universe, but whether we are prepared for contact with intelligences that understand our technology well enough to map its vulnerabilities with surgical precision while remaining completely invisible to our most sophisticated detection systems. In the careful analysis of those impossible weeks, a pattern emerged that transformed our understanding of what had transpired in the orbital space above our world. The satellite disruptions weren't random events scattered across time. They followed a methodical sequence that suggested systematic evaluation rather than coincidental interference. Something was conducting what could only be described as a comprehensive examination of human technological capabilities. The timing revealed the architecture of the assessment. GPS satellites experienced anomalies during the first week of our visitors' approach, allowing whatever was conducting this evaluation to observe how ground controllers detected navigation system failures and what backup procedures they implemented. Communication satellites were probed during the second week, testing the resilience of international data networks and emergency communication protocols. Earth observation systems experienced disruptions during the third week, revealing how quickly environmental monitoring could be restored when space-based sensors went offline. Each category of satellite technology was examined during its own dedicated time window, as if something was methodically working through a checklist of human orbital capabilities. The sequence suggested not random interference, but deliberate intelligence organizing its assessment to avoid overwhelming human response systems, while gathering maximum information about our technological infrastructure. Most remarkably, the disruptions seemed calibrated to test specific operational thresholds. GPS timing errors lasted exactly long enough to trigger automated error correction protocols without causing permanent synchronization failures. Communication blackouts were brief enough to activate backup systems, but not long enough to create cascading network failures. Weather satellite anomalies occurred during windows when ground-based radar could provide temporary coverage, preventing gaps in meteorological monitoring that might affect public safety. This surgical precision implied intimate knowledge of human technological architecture. Random cosmic phenomena don't understand the difference between primary and backup communication channels. Natural space weather events don't time their effects to evaluate emergency response procedures. Solar storms don't coordinate their impacts to test the resilience of redundant systems without causing permanent damage. Something was demonstrating understanding of human technology that exceeded the knowledge of many of the engineers who had designed these systems. The disruptions targeted precise vulnerabilities while avoiding critical failures, mapped system interdependencies while maintaining operational safety, and assessed response capabilities while minimizing actual disruption to civilian services. The geographical patterns provided additional evidence of systematic evaluation. Satellites serving different regions of Earth experienced anomalies in sequences that allowed for comparison of how different ground control centers detected, analyzed, and responded to identical types of system failures. European, American, and Asian satellite operations were probed during different phases of the assessment, revealing variations in emergency protocols, backup procedures, and interagency coordination. This global scope implied surveillance capabilities that could monitor human activities across multiple continents simultaneously. Whatever was conducting this evaluation had access to information about satellite operations, ground control procedures, and emergency response protocols that should have been protected by the highest levels of operational security. The assessment extended beyond technical capabilities to include institutional responses. How quickly did different space agencies acknowledge satellite anomalies? What language did they use in their incident reports? How effectively did civilian and military satellite operators coordinate their responses to simultaneous disruptions? How much information about the anomalies was shared publicly versus classified for internal analysis? These were not questions that natural phenomena typically pose. Random space weather events don't evaluate human bureaucratic procedures. Cosmic ray bursts don't assess the effectiveness of inter-agency communication protocols. Solar particle events don't test the boundaries between public disclosure and operational security. The evaluation seemed designed to map not just the technical characteristics of human orbital infrastructure, but the social and institutional frameworks that governed its operation. Something was learning how human civilization organized itself in space, how it responded to unexpected challenges, how it balanced transparency with security, how it coordinated responses across different nations and agencies. The timing of the assessment relative to our visitor's trajectory provided the most compelling evidence that these events were not coincidental. The disruptions began before our interstellar guest reached its closest approach to Earth, suggesting that the evaluation was initiated when our visitor was still beyond Mars' orbit. They continued until weeks after it had passed our planet and begun its journey toward the outer solar system, indicating that the assessment required extended observation periods to gather comprehensive data. This timeline implied planning and coordination that extended across interplanetary distances. Whatever was conducting this evaluation had begun its preparations when our visitor was millions of miles away from Earth, had maintained continuous monitoring throughout the passage, and had concluded its assessment only after gathering sufficient information about human technological capabilities and response procedures. The scope and sophistication of this evaluation suggested capabilities that challenged fundamental assumptions about interstellar travel and communication. Something associated with our cosmic guest could coordinate activities across vast distances, maintain surveillance of multiple satellite systems simultaneously, and conduct systematic assessments while remaining completely undetectable to human monitoring networks. But perhaps the most unsettling aspect of this evaluation was its apparent success. Whatever was conducting the assessment had achieved comprehensive mapping of human orbital infrastructure without triggering emergency protocols, without causing permanent system damage, without generating public awareness of what was happening. The evaluation had been completed with such subtlety that most of the world remained unaware that their technological civilization had undergone systematic examination by an intelligence that understood its vulnerabilities better than its creators. The implications were staggering. If something could conduct such detailed assessment of human capabilities while remaining invisible to our detection systems, what other activities might it have accomplished during our visitor's passage? What other aspects of human civilization might have been evaluated? What conclusions might have been drawn about our technological sophistication, our defensive preparedness, our readiness for contact with intelligences that operated according to principles we didn't understand? The satellite disruptions might have been just one component of a much larger evaluation. While ground controllers were focused on orbital anomalies, what else might have been examined? Communication networks, power grids, transportation systems, financial markets, any aspect of technological civilization that depended on electromagnetic coordination might have been accessible to intelligence that could touch our satellites with such precision. The evaluation revealed asymmetries in capability and knowledge that were profoundly unsettling. Something could observe human activities without being observed in return. It could assess our technologies without revealing its own. It could map our vulnerabilities while keeping its capabilities completely hidden. This represented not just technological superiority, but strategic advantage of a magnitude that challenged every assumption about humanity's place in the cosmic order. Yet the evaluation had been conducted with remarkable restraint. No systems were permanently damaged, no critical services experienced extended outages, no cascading failures were triggered that might have caused widespread disruption or public panic. The assessment had been thorough but gentle, comprehensive but careful, revealing but not destructive. This restraint might have been the most significant aspect of the entire evaluation. Something with the capability to systematically disrupt human orbital infrastructure had chosen instead to conduct surgical probes that gathered information without causing harm. The decision to limit the assessment to temporary recoverable anomalies suggested not just technological sophistication, but ethical considerations that governed the use of superior capabilities. Or perhaps the restraint reflected strategic calculation rather than ethical constraint. An intelligence conducting systematic evaluation of potentially hostile civilization might choose subtle assessment over destructive testing to avoid triggering defensive responses that could interfere with data gathering. The gentle nature of the probes might have been designed to ensure that human controllers interpreted the anomalies as system malfunctions rather than external interference. The evaluation also demonstrated understanding of human psychological and institutional responses that was remarkably sophisticated. The disruptions were calibrated to fall within the range of anomalies that satellite operators might experience during routine operations. They were brief enough to be dismissed as temporary glitches. They were subtle enough to be explained by conventional technical analysis. They were coordinated enough to reveal patterns to careful observers, but not dramatic enough to trigger widespread alarm or media attention. This psychological precision implied deep understanding of how human institutions process extraordinary information. Something had calculated exactly how much disruption would be attributed to routine system failures, how much correlation would be dismissed as coincidence, how much pattern recognition would be suppressed by bureaucratic procedures, and the human tendency to normalize unusual experiences. As our interstellar visitor continued its journey toward the outer solar system, and the satellite anomalies faded to statistical insignificance, the questions raised by this systematic evaluation continued to echo in the spaces between official explanations. What had been learned about human civilization during those weeks of impossible assessment? What conclusions had been drawn about our technological capabilities, our defensive preparations, our readiness for contact with intelligences that operated by rules we didn't understand? The evaluation had been completed with such thoroughness and subtlety that we might never know the full scope of what had been examined. But we could be certain that something now possessed detailed knowledge of human orbital infrastructure, institutional response procedures, and technological dependencies. Something understood our capabilities and vulnerabilities better than we understood them ourselves. In the gentle precision of those satellite probes, we had encountered intelligence that could reach across interplanetary space and touch our most sophisticated systems with the delicate accuracy of a scientist examining specimens under a microscope. We had been studied, assessed, and catalogued by minds that operated according to principles we couldn't comprehend, using methods we couldn't detect, pursuing purposes we could only begin to imagine. The most profound question raised by this evaluation was not what had been learned about human technology, but what the assessment revealed about our readiness for contact with intelligences that possessed such capabilities. Had we passed this examination, or failed it? Were we judged to be sophisticated enough for further interaction, or too primitive to merit continued attention? Were we perceived as potential partners in some cosmic community, or as subjects requiring continued observation and study? The satellite disruptions had ended, but the evaluation might have been just the beginning. Something in the vast darkness between stars now carried detailed knowledge of human civilization back toward the cosmic depths from which our visitor had emerged. And in that knowledge lay implications that would echo through human consciousness long after our interstellar guest had disappeared beyond the edge of our solar system. When systems flickered in sequence across our orbital network during those strange autumn weeks, something had been asking fundamental questions about the civilization that had learned to build machines in space. Questions about our capabilities and our limitations. Questions about our wisdom and our readiness. Questions about whether humanity was prepared for the responsibilities and challenges that come with contact between civilizations separated by vast distances and profound differences in technological capability. The answers to those questions were now traveling toward destinations we couldn't imagine, carried by intelligence we couldn't comprehend, for purposes that remained as mysterious as the visitor that had conducted this most careful and comprehensive examination of everything humanity had built in the darkness above our heads. Violence, we have learned throughout human history, does not always announce itself with explosions and destruction. Sometimes the most profound acts of power manifest as silence, the absence of expected signals, the failure of trusted systems, the gentle demonstration that what we thought was secure can be touched by forces we never anticipated. In those autumn weeks when our satellites flickered and stuttered in their orbits, we encountered a form of influence that was far more unsettling than any dramatic display of destructive capability. Our interstellar visitor had not come as a conqueror, wielding weapons that could shatter worlds or burn civilizations to ash. Instead, it had arrived as something far more sophisticated, an intelligence capable of reaching across the void and touching our most protected technologies with the precision of a master craftsman, demonstrating control without destruction, influence without violence, assessment without alarm. This was not the cosmic contact that generations of human imagination had envisioned. No massive ships appearing in our skies, no dramatic pronouncements broadcast across all frequencies, no ultimatums delivered to world leaders or messages of greeting transmitted to radio telescopes. Instead, something had whispered to our machines in languages we couldn't understand, conducting conversations with our orbital infrastructure that left no transcript we could read. The satellite anomalies were not attacks in any conventional sense. They were demonstrations, proof of concept, evidence that human technological civilization, for all its sophistication and careful engineering, remained vulnerable to influences that operated outside the boundaries of our scientific understanding. Something had shown us, with gentle precision, exactly how thoroughly our defences could be penetrated by intelligence that understood our systems better than we understood them ourselves. In the measured response to these impossible events, we glimpsed the institutional mechanisms that protect human societies from acknowledging truths too large for comfortable comprehension. The anomalies were documented, analysed and archived. They became data points in technical databases, footnotes in operational reports, statistical outliers that fit within the acceptable range of unexplained phenomena that complex systems occasionally produce. This is how civilizations protect themselves from paradigm-shifting revelations, not through active suppression or deliberate cover-up, but through the comfortable weight of established procedures and the human tendency to normalize extraordinary experiences when they don't fit existing conceptual frameworks. The impossible becomes invisible through bureaucratic routine, extraordinary becomes routine through institutional inertia, revolutionary becomes evolutionary through the gradual accumulation of unacknowledged evidence. But for those who understood what had happened during our visitor's passage, the implications could not be normalized or archived away. Something had conducted a comprehensive assessment of human technological capabilities while remaining completely undetectable to our monitoring systems. It had mapped our vulnerabilities, tested our responses, and catalogued our defences with thoroughness that exceeded our own understanding of the systems we had built. The psychological impact of this realization extends far beyond technical concerns about satellite security or orbital infrastructure resilience. We had discovered that we were not alone in our corner of the galaxy, but the nature of that discovery challenged every assumption about how contact between civilizations might unfold. We were not the discoverers but the discovered, not the observers but the observed, not the examiners but the examined. Our visitor had possessed capabilities that allowed it to study human civilization with the detached precision of scientists observing laboratory specimens. It could affect our technologies without triggering our detection systems. It could map our responses without revealing its methods. It could assess our readiness for contact while remaining completely hidden from the instruments we developed to search for exactly such intelligence. This asymmetry in capability and knowledge represented a fundamental shift in humanity's understanding of its place in the cosmic order. We were no longer alone, but we were also no longer in control of the circumstances under which contact might occur. Something had already made that decision for us, conducting its evaluation according to criteria we couldn't understand, reaching conclusions we might never be allowed to know. The restraint shown during this assessment might have been its most significant aspect. Something with the capability to systematically disrupt human orbital infrastructure had chosen instead to conduct surgical probes that gathered comprehensive information without causing permanent damage or widespread alarm. This suggested not just technological sophistication, but ethical frameworks that governed the use of superior capabilities. Or perhaps the restraint reflected strategic calculation rather than ethical constraint. An intelligence evaluating potentially hostile civilization might choose subtle assessment over destructive testing to avoid triggering defensive responses that could interfere with data gathering or escalate into conflicts that served no useful purpose. Either interpretation carried profound implications for humanity's future. If the restraint reflected ethical considerations, it suggested the possibility of contact with intelligence that recognized moral boundaries and operated according to principles that valued preservation over destruction. If the restraint reflected strategic calculation, it implied intelligence sophisticated enough to conduct long-term planning that balanced information gathering against risk management. But there was a third possibility that was perhaps more unsettling than either ethics or strategy. The gentle nature of the satellite probes might have reflected simple indifference, the restraint that a researcher shows when studying insects, not from ethical concern for the insect's well-being, but from recognition that damaged specimens provide less useful data than intact ones. This possibility transformed the entire context of our visitor's assessment. We might have been examined not as potential equals deserving ethical consideration, not as potential threats requiring strategic evaluation, but as subjects of scientific curiosity whose civilization was interesting enough to merit detailed study, but not significant enough to require diplomatic contact or defensive preparation. The implications of each interpretation were staggering, but they all led to the same fundamental conclusion. Humanity was no longer alone in the universe, and the circumstances of contact were being determined by intelligence that possessed capabilities we couldn't match and operated according to principles we couldn't comprehend. As our interstellar visitor disappeared beyond the edge of the solar system and the satellite anomalies faded to statistical insignificance, the questions raised by those weeks of impossible assessment continued to echo through human consciousness. What had been learned about our civilization during that systematic evaluation? What conclusions had been drawn about our technological sophistication, our social organization, our readiness for contact with intelligence that operated by rules we didn't understand? Most unsettling of all, what did the completion of this assessment mean for humanity's future? Had we passed some cosmic examination, or failed it? Were we judged worthy of further contact, or dismissed as too primitive for continued attention? Were we perceived as potential partners in some galactic community, or as subjects requiring continued observation and study? The silence that followed our visitor's departure was perhaps more profound than the silence that had preceded its arrival. Before, we had been alone in what we believed was an empty universe. Now, we were alone in what we knew was a populated cosmos, carrying the knowledge that our technological civilization had been thoroughly examined by intelligence that understood our capabilities and vulnerabilities better than we understood them ourselves. In the months and years that have passed since those strange autumn weeks, satellite operations have returned to their normal routines. New systems have been launched, older ones have been decommissioned. Routine maintenance and upgrades have proceeded according to established schedules. The extraordinary has been absorbed into the background noise of institutional memory, becoming historical footnotes in technical databases that few will ever examine. But the questions persist in the spaces between official explanations. In control rooms where operators monitor the eternal dance of mechanical guardians above our heads, some remember the patterns that couldn't be explained by conventional analysis. In classified briefings where the implications of systematic satellite assessment are discussed in carefully measured language, some acknowledge possibilities that challenge fundamental assumptions about humanity's place in the cosmic order. And in the broader human consciousness, carried by those who understand what happened during our visitor's passage, lies the knowledge that we have been seen, studied, and catalogued by intelligence that operates according to principles we cannot comprehend. We have been touched by something from the vast darkness between stars, and in that touch we discovered that the universe is not the empty, indifferent void we once believed it to be. The meaning of our visitor's silent assessment extends far beyond the technical details of satellite anomalies or the institutional responses to unexplained phenomena. It represents humanity's first confirmed contact with intelligence from beyond our solar system, conducted on terms we didn't choose, according to methods we couldn't detect, for purposes we can only imagine. We are no longer alone, but we are also no longer in control of how that fundamental reality unfolds. Something in the cosmic darkness possesses detailed knowledge of human civilization and technological capabilities. Something has conducted a comprehensive evaluation of our readiness for contact with intelligence that understands our vulnerabilities better than we understand them ourselves. The satellite disruptions have ended, but the assessment they represented may have been just the beginning. Somewhere in the vast space between stars, Intelligence that touched our machines with invisible precision carries information about human civilization toward destinations we cannot imagine. And in that information lie the seeds of humanity's future relationship with a universe that we have discovered is far more complex, far more populated, and far more dangerous than we ever dared to believe. When our satellites flickered in their orbits during those impossible weeks, something was asking fundamental questions about the species that had learned to build machines in space. Questions about our wisdom and our readiness. Questions about our capabilities and our limitations. Questions about whether humanity was prepared for the responsibilities and challenges that come with membership in a cosmic community, where intelligence takes forms we cannot predict and operates according to principles we cannot understand. The answers to those questions are now travelling through interstellar space, carried by visitors we cannot track toward destinations we cannot fathom. And in the silence that follows their departure, we are left to contemplate the most profound question of all. What did our evaluation reveal about our readiness for a universe where intelligence is not unique to Earth, where technology is not limited to human understanding, and where contact between civilizations might occur according to rules we never imagined and schedules we cannot control? Perhaps the real message was not in what our visitor showed us about the cosmos, but in what it quietly revealed about the fragility and vulnerability of the technological civilization we have built in the space above our heads. In those gentle disruptions, we glimpse both the extraordinary achievements of human engineering and the sobering reality that our most sophisticated defenses remain permeable to intelligence that chooses when and how contact occurs. The sky above us continues its eternal dance of mechanical guardians, maintaining the invisible connections that hold our technological world together. But now we watch that dance with different eyes, knowing that it can be touched by visitors from the dark between stars, knowing that our machines can whisper secrets to intelligence we cannot detect, knowing that we have been examined by minds that operate according to principles we cannot comprehend. In the end, the meaning of that silent assessment may be found not in the answers it provided, but in the questions it left echoing through human consciousness long after our interstellar visitor had disappeared beyond the edge of our solar system, carrying with it knowledge of who we are, what we have built, and perhaps most importantly, whether we are ready for the universe we have discovered we actually inhabit.